Good day. Today we will tell about the very important topic, Bravais lattice. Here you can see the plan of our lecture. The first, the shapes of elementary cells. Then we will tell about the three conditions. And the first, including the types of Bravais lattice. What is it, Bravais lattice? Based on the idea of the periodic arrangement of the center's mass material particles in 1848, Bravais showed that the diversity of crystal structures can be described using 14 types of lattice with different shapes of unit cells and symmetry. These lattices are called Bravais lattice, and they are the basis for the classification of crystals by symmetry. Bravais lattice is a translation group that characterizes the locations of the material particles in space. To select a Bravais lattice, there are used three conditions. First, the symmetry of a unit cell must correspond to the symmetry of the crystal. The edges of the unit cell must be translations of the lattice. The second, the unit cell must contain the maximum number of right and equal angles and equal ribs. And the last condition, the third, the unit cell must have the minimum volume. These conditions must be executed sequentially. Other words, when selecting the cell, the first condition is more important than the second one, and the second one is more important than the third one. Nature of intersection or mutual arrangement of sides or Bravais lattices are divided into four types. The first type, primitive, the symbol P. The second type, base-centered, symbol C, B, or A. The third, body-centered, the symbol I. And the face-centered, the symbol F. In a primitive cell, all lattice sides are located only at the corners, and complex cells are more similar sides. Maybe B, maybe A. It depends on the face. And the last type, face center, is at one side or in each face, here and here. The unit cells of Bravais are the basic cells that are characterized by the crystal symmetry. By adopting one of the sides of the space lattice is origin, for the side with the symbol 0, 0, 0, you can find all other sides of the lattice with a translational group, a set of co-translations of the unit cell. The translational group for all types of cells in each symmetry is given in this table. To highlight the structure of the Bravais unit cells, we must find the three shortest non-complanar translations A, B, C, and each translation must begin and end at the same sides. Next, you need to check the module requirements. Number one, whether it is possible to build on these translations a cell that meets the rules of the Bravais cell selection. Number two, whether all the particles in the structure can be obtained using a set of translations. And a system of coordinates of the sides belonging to a unit cell is called a basis cell. Here you can see this. The entire crystal structure can be obtained by repeating units of the basis set of translations of the Bravais lattice or cell. In this case, the origin is selected at the top of the cell, and coordinates of the sides are expressed as a fraction of the elementary translations A, B, C. And here you can see the translational group for the primitive body center, A, B, C, face center, and I. Here the major translation, basis, and the number of sides in a cell. For example, face-centered symbol F. The major translation A plus B derived 2, B plus C derived 2, C plus A derived 2, and of course A, B, C. The translational group or basis 0, 0, 0, and 1 derived 2, 1 derived 2, and 0, 1 derived 2, 0, 1 derived 2, and 0, 1 derived 2, 1 derived 2. The number of sides in a cell is 4. The primitive, of course, is the simplest type of Bravais cells. The major translations A, B, C, the basis 0, 0, 0, and of course it's obviously the number of sides in a cell is only 1. In conclusion of our lecture, I want to tell that Bravais showed that the diversity of crystal structures can be described using only 4 types of lattice, and these types of lattice are different from each other, the different shapes. And it's clear that every type of Bravais lattice can be obtained by the repeating the translational group, the basis of this cell. Thank you.